Hello learners, welcome back to our channel Chemistry Daily. Today onwards, we see the concepts from the chemical equilibrium. Okay, let's move to the today's session. Today we see about the what is equilibrium. That means chemical equilibrium and chemical equilibrium constant. And the chemical equilibrium contains two types. One is heterogeneous and homogeneous. So, and in next classes we see about what is Lee-Chatelet principle and how it's based upon the temperature, pressure, volume, and reactant and products. So, first we see about the chemical equilibrium. Chemical equilibrium is generally explained by use the equation is contain the equilibrium state. And it contains the forward and backward reaction because the number of particles involved in the reaction is totally converted into the product, and the product is for then get back to its reactant. So in the pictures we see the A plus B forms AB, and then again the AB converted into A plus B. So this is known as the equilibrium condition, and it's also if goes to the forward and backward reaction, and also it's equal. So the equilibrium has the certain characteristics. The character one is the equilibrium at the given temperature, the observable properties are pressure, concentration. So at the pressure and concentration, how the equilibrium it's not changed. It's contain almost both forward and the backward reactions, and also it's approached in either direction. First we go to front or forward, or next backward, or first backward or forward. So it's either direction. And in this reaction there is a catalyst also we used. So the catalyst does not change the equilibrium position. It's only react with the it's only alter the speed only, not change the equilibrium. And also it's appear in the dynamic in nature. So these are the four points are characteristics of equilibrium. So the equilibrium is characterized into two types. One is homogeneous equilibrium, other one is heterogeneous. The homogeneous, we also need the reactants and products are both are in same physical state. For example, it's either gas or solid. For example, here we have N2O4 and NO2 changes. Both are in the gas phase. So the homogeneous are involving only gases and solution, and its reactant and products are same physical state. Another one example is H2 and O2. It forms H2O. Both are in the gas phase. And second one type is the heterogeneous phase, and it have different phases. So for example, we see the CaCO3. It forms CO2 gas and CaO solid. So it forms both solid and gas. So it forms the different of physical state or more than one physical state. So these are called as the heterogeneous equilibrium. Then in the equilibrium we use the one constant that is known as the equilibrium constant. The equilibrium constant is the for example, it's explained by using the concentration of reactant and product at the equilibrium at given temperature. For example, we A plus D is the one of the reactant and it forms the C plus D. It's a reversible reaction. So for that one, we find the equilibrium constant is Kc is equal to concentration of the product divided by the reactant. So the equilibrium of the constant is defined by the concentration of the, it's a ratio of concentration of product and the ratio of concentration of reactant in the equilibrium mixture. So the Kc is equal to concentration of C into concentration of D divided by concentration of A into B. The Kc is known as the equilibrium constant. Next we see about the how we represents the equilibrium concentration. For example, we have the balanced reaction AA plus BB and CC into DD. According to the law of mass of action, the equilibrium we have know that how the uh, equilibrium constant is written. In this case, we have before some coefficients. For example, it may be mole, or it may be number of reactant, number of product. So for that one reaction, we have how to return the equilibrium constant. For forward reaction, Kc is equal to, we have already written concentration of C into concentration of D by concentration of AB. In that one, we use the coefficient in power. So what is the coefficient of C? Small c. So its powers. What is the coefficient of D? Small d. So divided by A power E and the concentration of B into B. So for example, this is for the forward reaction. So in such case, it's have both directions. So in a backward reaction, what happened? These are the reactant and these are the product. So we have inverse the forward reaction equilibrium constant. So the Kc written as Kc dash. So it's in inverse. So we have to return the reciprocal form. So what happened? These are the products. So A power A, B power B divided by C power C into D power D. So this is the how representation of equilibrium constant. So for example, here the Kc means we have expressed the equilibrium constant in the base of concentration. In such a case, we have note the partial pressure. It's Kp. For Kp, we have written that for before we have used the for remove the concentration, use the word P. P represents the partial product. For Kx, X means what we see in the previous videos. It's mole fraction. So for mole fractions, we written the mole so in the square bracket we have written the mole fraction xc xd divided by xa and xb. So there are three types of equilibrium constant, kc, kp and kx, and these are the terms, expressed terms. Okay, learners. Today we learn about the what is the chemical equilibrium and how chemical equilibrium is classified into two types. One is homogeneous, another one is heterogeneous. Homogeneous has the same phase in the both forward and reactant, and heterogeneous has different phase and different one or more phase in the reaction. So the homogeneous H2 and O2 forms the H2O, and here the heterogeneous, the C is these forms the both gas and solid one. So these are the more than one in the formed in the heterogeneous. And how the equilibrium constant is written. For example, A plus B forms the AB. We have to return that the concentration of the product in the above and concentration of reactant in the below one. So this is the ratio of concentration of product to the reactant. And we have written the before it contains any coefficient value. So it's denoted in the power. For forward, the before the equal to before that one is the reactant, and after that equal is the product, and backward these are the reactant, these are the product. So we have to return like that. And also we have how to we see how to return the partial pressure equilibrium constant and a partial molar constant equilibrium. So molar equilibrium constant for mole fraction. So I hope we have the some ideas from today's video. In next video we see the another interesting topic. Thank you for watching. Thank you.